Still loading. All right. You guys know you have a YouTube channel. Still loading. All right. So that's good. So we talk about the reciprocal ratios. Basically, secant mean the reciprocal of sine. You flip the ratio of sine. And cosecant. Secant mean you flip the reciprocal of cos. And then cotangent mean cotangent of theta, you flip the reciprocal of tan, which is going to be 2. I didn't do that correct. And then you guys say correct. Cotangent of theta is going to be 2. Make sense? How many of you have a calculator? You have a calculator, sir? You have a calculator? I'm a mobile device. Do you have a calculator? On your phone. All right. Phones are allowed in this class. So what we want to know right now, how we can able to find out the angles measure using a calculator. So tan of 40. I gave my calculator back to one of my students because at her school, she's allowed to use any calculator. The exact value calculators. So I had an exact value calculator because she's struggling on exact value and trigonometry unit. So I had a calculator. I show you how to get an exact value because your teacher allows you to use the calculator. Here's how to use it. You use it and then let me know whether your teacher is permitting. Okay, tan of 40. So let's see who can give me a tan of 40. I don't have my calculator with me. Well, I can't bring my calculator. Do I need to bring my calculator? 4 decimal places. Just give me a moment. Let me put my tomorrow. I will be evaluated for my teaching, but I need my iPad, so I don't want to leave my iPad. I will bring my calculator. Just give me a moment. 4 decimal places. Fancy calculator, Texas Instrument, colorful display, programmable calculator. It can be programmed in Python. I bought it. So this one comes as a set, rechargeable. This one can be connected to a robot, little robot on the bottom. It's called the rover, has 3 wheels. So you basically program on your calculator and then you connect to the robot can move. For example, if I program to create a circle, it will actually draw a circle. So it's attached to it. But the one set with the calculator and the robot itself costs $1,300. The calculator around $20 worth because it's a graphing calculator with a colorful display. All right, so now tan 40. What did you guys get for tan 40?
0.8391.
What did you get? Tan?
Oh, you got switch.
Oh, no. I want to say, yes, Chinese calculators are useless. You just flip it.
Now they have a new. Are you on iOS 18? Oh.
What kind of calculator you have? No, flip it, lady, like that.
Off your screen lock. Do you have the thing where it doesn't rotate? Yeah.
Oh.
Now you need to press the tan. You need to press 40 and then tan because it doesn't work the other way around. You press the 40. You press the 40 and tan, and then you should be able to get the value.
I think that's right.
What?
It's a negative value.
Yeah, it's because the calculator is in the wrong mod.
Yeah.
So do you see on the corner here on the calculator, there's a degree and radian. You need to switch it back to degree. Do you switch degree? Lady, on the corner, what is display? Is R80?
Yeah.
So then press 40 first. Can you type 40 first?
Yeah.
And then press the tan button. What did you get?
0.8.
That's what he said. So 0.8399 to the nearest 100. So nearest 100 means 0.839. Nearest 100 is going to be 0.84. Makes sense? But the problem is, does your calculator have a button called cosecant?
No.
So then we have a problem. How are we going to find it? We know cosecant is 1 over sine 19, isn't it? Because it's reciprocal of sine. Make sense, sir?
Yeah.
Can you guys find out what is 1 over sine 19 is on your calculator? Let's see. I have an answer, sir. What do you got?
I got 3.07.
That's right. How about you, sir?
3.07.
Nearest 100. So nearest 100, 3.072. Makes sense? All right. Are you following that?
Yeah.
Okay. So secant 25. Obviously, we can find it as going to be 1 over cos 25, isn't it?
I got 1.1.
What do you get?
1.1.
Pretty good, so 1.1. All right, 1.103. So that is going to be 1.10. Pretty good. Something we didn't do it here. What we didn't do here is they also asked to find the angle. Yes? So how to find the angle is something that you need to know. Let's going back to the sine of theta. So I find a sine of theta is root 5 over 5, isn't it? How do I find the angle if I know the sine ratio? Divya, what should I do to find a sine ratio?
Cross multiply?
No, that doesn't work.
The inverse.
Inverse. Theta is equal to sine inverse of root 5 over 5, isn't it? Make sense? So can you guys find out what a sine inverse is going to be root 5 over 5? Who have an answer? Who has the answer? Yes,
27.
that's right. But 26.56. We're going to round it to the nearest 10. So 26.6 degrees, isn't it? Not easy with the calculator on the phone. Sorry. So this is going to be theta is 26.6 degree. Now, how do I find this angle? Well, we know all three angles add up together 180, isn't it? So we can able to subtract from 180 minus 90 minus 26.6. You know how to do that after, so I don't need to tell you. And that's all.
No, I kind of got lost.
What is the sum of the interior angle in a triangle?
180.
So if I know that theta is 26.6, how do I find the angle C? Because all what the B is going to be 90.
Yeah. So just subtract it from 180.
180 from, yes. Makes sense?
Yeah.
Yes.
Wait, how did you find out it was 26.6?
So you see sine of theta is this, right?
Yeah.
To find a theta, this operation is sine inverse.
Mhm.
So if you give the ratio, it will give the angle. So on the calculator to do that, so you flip it. When you
Wait,
flip,
mine stays the thing.
oh, pretty good. Okay, iPhone 16.
Nah, it's just need
Just you
iOS
lock.
18.
What?
You just need iOS 18.
Oh, just to keep that.
Yeah.
All right. So you're gonna go back to the root 5 over 5. So you need to add root 5 over 5, or I'm gonna say 1 divided by root 5, right? So 1 divided by root 5. You see that?
Mhm.
Actually, this is iOS 18 using the other way around. Pretty good. So let's clear out memory clear. How do I clear it?
It should be
AC. Yeah. So you can go back to second function and then sine inverse. Yes.
Yeah.
And then you're gonna get root 5 over 5. Root 5 And then you need to divide it by 5. So I need to put the bracket. So root 5 divided by 5. It's a division button divided by 5.
Yeah, I did not know what that second button did at all.
Yes, because you have a fancy phone, but you don't know how to use your calculator. This is iPhone. What are you saying? iPhone
14 Pro.
14 Pro?
Yeah.
Do you like the camera?
Oh, yeah, it's pretty good.
Right?
It's pretty
The
good.
cameras on the 14 Pros are good, not
Yeah.
that the double. Well, I have a 3 camera, but I have an iPhone 15. I'm not sure. All right. Do you know how to use it?
Kinda.
Kind of. So in your calculator, there's a second function,
Yeah,
and then
I
you
know
click the
that.
sign. But the problem is your calculator work other way around. First, you need to type root 5 over 5 first. You need to print a number first, then the second function, then the sign function. Okay. All right. Now, you guys know how to deal with this, how to find the inverse. So can you guys tell me what is the angle theta is going to be using sine inverse function? Let's see, how would you guys do that? So when sine of theta is equal to 6 over 10, theta is equal to sine inverse of 6 over 10, isn't it? Make sense? Right? Okay, can you guys find the answer?
Wait, so would all these be like inverse?
Sorry?
Would
Yeah.
all be okay?
Yeah. All right. So what do you guys got to sine inverse of? Sine inverse of that.
I got 36.869.
Right. 36.89, that's right. 36.869. So nearest degree. So we're gonna say that is going to be 36.869. So we're gonna say 37 degree. Make sense? How do we work with the secant theta? Because you can't really find the inverse of secant. There's no button on the calculator. But what we know as secant is 1 over cos, isn't it? Are you following that?
Yeah.
Therefore, cosecant is, you need to flip it, 1 over 1.5. Make sense?
Yeah.
Because 1 over cos is this, cos must be flipped.
Yeah.
Therefore, theta must be what? Cos inverse of that ratio, isn't it? Make sense? Okay, can you just tell me what you just got if you can't able to do the math? Sorry, you need a calculator for this for a while.
44.061.
Everyone agree with that?
Yeah.
So 44 degree approximately, wrote down it, right? Okay, you guys gonna be tell the theta. So you know what's cotangent is, reciprocal of tan, right, Tavia? Okay, can you just do the math and tell me what did you guys get? All right, what did you guys get for the cotangent?
I have a question.
Yeah.
When you flip it, do you flip it to 4/7?
Yes, that's right. Who has the answer for my cotangent? What do you have?
I got 29.7.
That's right. Yeah. So that you do tan theta is equal to 4/7. So theta is equal to tan inverse of 4/7. So that's give you 29.74. 30 degree. Makes sense. All right. Now what we're gonna going back to? We're gonna going back to a question that involves a triangle. So how we should be able to use the triangle to find out. So in a triangle ABC, angle A is 90 degree. So I'm gonna sketch my diagram. Angle A is 90 degree. Now, in grade 10, you learn a standard notation. The length across A will be labeled as A. The length across the B, angle B is going to be labeled as B. The length across the angle C is going to be labeled as C. Make sense? So in triangle ABC, A is 90, B is 12 centimeter, and then C is 20 centimeter. Solve the triangle. When they say solve the triangle, what they actually find looking for is, you need to find a value of A. You need to find a value of angle B. You need to find a value of angle C, isn't it? Can you solve for the triangle based on what you know from grade 10? Use your grade 10 skills to find out the missing information, please. This is just a review from your grade 11, grade 10 now. Done. So your teacher still just stuck on quadratic relation? That's kind of weird. At summer school, at night school,
Most of my work is just quadratic.
still in quadratic.
Yeah.
What they're doing at solving equations or
Yeah, and just like word problems.
now the word problems. Okay, now then you're gonna be going back to mixed functions. And even they will go back to trigonometry.
I think so.
All right. Very importantly here, you should not leave the answer for a in decimal. So you have to leave in radicals, isn't it? So if you use the Pythagorean theorem, 20 squared plus 12 squared, isn't it? You got 400 plus 144, isn't it? Square it up, 544. Makes sense? Are you following that? Yes? So 544, you can actually rewrite it. So this is a little tricky. Can I divide 544 by 4? Yes, I can do 136. So I can rewrite this 136 times it by 4. Can I do 136 by 4? Yes. So 136 divided by 4 is actually 34. So I can say 34 times 4 times 4. 34, I can't really do anything. So I can rewrite this. So this is 34 times 16. So square root of 16 times square root of 34. Square root of 16 is 4. 4 root 34. Are you guys following that? Guys, are you following how to get the exact value?
Yeah.
Are you supposed to subtract B?
Subtract B.
Because isn't it,
Oh yes. No, what you talking about?
it's supposed to be A squared equals C squared minus B squared.
No. Love this. This is a good learning moment. This is a good learning moment. I had a math teacher in grade 12. So we are learning grade 12, our 2.5 years preparation for solid maths if you want to be an engineer. First year of the class, so he asked my friend to stand up. What is Pythagorean theorem? My friend said, A squared plus B squared is C squared. He said, who's your grade 11 math teacher? Joseph Master. Go to Joseph Master and ask him, what is Pythagorean theorem? So he came back and Joseph Master says, A squared plus B squared, C squared. And say, what he said, A squared plus B squared, C squared. So he really had to get upset. How come he didn't teach the right Pythagorean theorem? That's exactly what you're saying, sir. What you remember Pythagorean theorem is, A squared plus B squared is C squared. What you don't know is what this really is about. And that's why you're confused right now. You need to subtract. What side I need to find out, man? The hypotenuse. How do I find the hypotenuse? Do I need to add the other two side squares?
Yeah.
So why do you need to subtract? And you know why you're subtracting? Because you're thinking A squared must be C squared minus B squared from the formula. This formula is useless. That is not Pythagorean theorem. That is a derivation of the Pythagorean theorem. You derive such an expression that's connecting the two sides of the hypotenuse. So I taught in grade 12 college math in City Adult Learning Center. It's an adult school. So still our curriculum, but college math. So I put a bunch of questions like that. But all I did is I changed my letters. I put an A different place, B different place. More than half the class failed because all they did it, they just put the numbers on the other way around. When you put the other way around, you don't really get the right expression. Are you seeing what the mistake is? You don't understand what I was talking about? Aaron says I'm wrong because Aaron is thinking about Pythagorean theorem this way. So he is thinking A squared plus B squared is C squared. So therefore, I need to find the A on my label. I don't say, well, if that's the case, from C squared, I need to subtract B squared, which I didn't do. Did I do it? I added.
You get the same answer?
No, you won't get the same answer. How would you get the same answer, lady? Because you're finding the hypotenuse. The hypotenuse is sum of the squares of the other two sides. Did you see A is the hypotenuse, isn't it? How would you find the hypotenuse? Sum of the squares of the other two sides, take the square root, isn't it?
Yeah.
So what his misconception is, he is thinking about from that formula. Are you just following that? You all good, sir?
Yeah.
So don't get misled because your teacher will put something like that on the test, and mark this 90 degree. And you will for sure will one thing about that is your hypotenuse. That is your hypotenuse. You will think about that's an opposite side. It's very easy to mislead. I will put the I. I'll get 4, 4. Then I've got some values 2 root 4. Let me see 2 root 2 times 4. I said, okay, this is root 2 times 4. Root 2 times 4. Then I asked to find out sine of theta. You know what you will do? Oh yeah, sine of theta. You're going to looking at the opposite as this is going to be the opposite side. But that is the longer side is the hypotenuse. So did you find the A? Everyone actually 4 root 3, 4? Yes?
Yeah.
What did you guys get for B? What did you get for B? Angle B. Anyone else have done angle B? Guys, angle B, keep your eye here, isn't it? If you keep the eye B here, if you're looking at the angle B, for the angle B, this distance is the opposite distance, isn't it? This distance is the adjacent distance, isn't it? So what I can write it for angle B, can I write tan of B? Tan of B is opposite over adjacent 20, isn't it?
Yeah.
So we can simplify that. So that's something you can do. But even without a simplification, you can go back to the calculator. How do you find a B? Tan inverse of 12 over 20, isn't it? Make sense?
Yeah.
Are you following that?
Yeah.
All right, what did you get? So tan inverse of 12 over 20.
30.963.
Makes sense. 31. Are you guys following that? Now, do I need to do any calculation to find a C? Do I need to use SOHCAHTOA to find a C? Why not? Yeah, so you can simply find out C is equal to what? 180 minus 90 minus 31, isn't it? Makes sense. I'm just following that.
Wait, it's opposite over adjacent, right?
For what, tan?
Yeah.
So you can see for angle B, the opposite is 12, the adjacent is 10, isn't it? How come you didn't upgrade your phone? You should have upgraded. Is it what your pattern is?
I'm like basically when I got this, I got it in March, right? So like I have the 2-year thing with Rogers. So I'll get the new one in March.
Okay, you need to wait for March 2025. Well, there's another way to get it. If you keep your phone in a nice quality, you can refurbish it.
Yeah. Well, that's what I do. I trade it in. Cause like it's not basically on lease.
All lease phone.
Yeah.
So that if you made a phone not in good condition, then you need to pay for
if it's damaged, then they just make you pay it off. But then if they can take it back, you can just get the new one.
It's like a car nowadays. The phone you lease it. I don't mind a lease phone, but that's a good financial decision because no one will keep the old phone.
Yeah.
There's no value at it. But car leasing is I don't think so. Well, if you buy a brand new car, yes, for sure it will depreciate in value. But eventually down the street in 7 years, you own the vehicle. And if the vehicle has a good lifetime, then you already paid for the vehicle. You only need to pay for the maintenance, right? But phone is not the way. The lifetime for this device is 5 years. After 5 years, you can upgrade. The battery's dead. All right, let's going back to the word problem. Are you guys ready?
I feel like the battery goes quicker than 5 years.
Yeah. Based on your charging pattern.
Yeah.
If you're the one you plug in overnight and then your battery will die in 3 years.
Yeah,
but
so
if you just plug it in and then it's full charge, you don't worry about it until 50% and the battery life. All right. Can you just do the next question by yourself without me helping you out? From a position some distance away from the base of the tree, Monik uses a clinometer to determine the angle of elevation at the top of the tree. Monik estimated the height of the tree is about 3 meters and the angle of elevation is 37 degrees. So angle of elevation is basically the angle you need to be really ratio phase to see it. So that is 37 degree. Calculate how far to the nearest 10 of the meter. Monica is from the base, so they want to find out M and N. Find M and. Can you just do that quickly? Pretty straightforward question. Using the information provided, you need to use one of the SOHCAHTOA. Okay, who has the answer? What ratio of TBI you can use to find the distance?
I don't know.
Don't you see that you need to find that distance?
Yeah.
You need to find an M and N, isn't it? So what do? We know the angle 37, isn't it? I will keep my eye here. When I keep my eye here, I will ask myself, for that eye, what is the MN related to? Adjacent, opposite, or hypotenuse? For the angle 37, what does the MN stand for? The adjacent side, the opposite side, so the hypotenuse? Adjacent side. Now, what side we also know? Opposite side.
Yeah.
So what ratio will connect the opposite with the adjacent in an angle?
10.
10. So we can write tan 37. Are you guys following that? Yes, no? Yes? You're not following the math,
Wait,
sir?
you just write MN?
Yeah, MN is the distance, right?
Yeah.
That's what you're going to find out. So you can do 3 divided by tan 37. What did you get, Aaron? Oh, you have a calculator.
I got 3.981.
Makes sense. Nearest 10th, 3.981. So if you add 1, it's going to be 4.0, isn't it?
Yeah.
Are you seeing that? So I do have some textbook questions. We can check that out before we proceed. So let me pull out the textbook to practice some questions before we move on. Do you play video games?
Me?
Yeah.
Yeah.
What do you play?
2K.
Everyone's telling 2K. Is that the basketball game?
Yeah.
But you had to play on the console?
Yeah.
And then displays on the TV?
Nah, I use a monitor.
Oh, a big monitor?
Yeah. I mean, I have 2.
How about you? 2K?
Yeah.
Wow, 6 good basketball guys. Is it a cool game?
Yeah, I mean, sometimes like they're releasing a new one every year. So some years it's bad, but this year's pretty good.
Like you will be part of the player to shoot?
Oh yeah. So like I mean, there's different game modes. You could play as like a team, or you could like have your own player. Like you just create your own player
and then play.
and they have their own career.
right, so 5.1, what we talk about it. So I'm gonna give you guys some questions to see if you can answer it. All right, so you guys can looking at the word problem. You're gonna do it by yourself. So let me know this question so I can show you. Yeah, I'm in the right section. Where did this go? I did send in to MCR here, but kind of weird. Where does this go? Okay, it's okay. Today is.
Are these a textbook question?
Yeah, it's a textbook question. Okay, so I will just show the question here. All right, guys. So you guys gonna looking at number 11. The height is flying 8.6 meters above the ground at an angle of elevation. Calculate the length of the string to the nearest tenth of the meter needed to fly the height using primal or trigonometric ratio and a reciprocal trigonometric ratio. I try to see why can't I put the screenshot? Hold on. I'm just saying it could send me one note. Okay, so okay, I know the problem. MCR3 new section. Okay, send it so you can see it. Here we go. All right, you guys do number 11. You guys all thinking? Yes. All right. Let's see. What did you guys do? Let's see what he has said. Correct, sir. You're on my track. Diagram makes sense. Let's see. What did you have? What did you draw? That's correct. Yes. Okay. So you define that length. Pretty good. Length of the string. Let's see. What do you have, sir? That is right. Yes. So you define this, isn't it? Yeah. Okay. Can you find that out? You can serve the cell. You're hungry. You wait for your coiled food. So like, actually, my son likes it. Like the quail soul, right?
Yeah.
All right, what's going up? You guys draw the diagram correct. So the height is flying 8.6 meter above the ground. So that's 8.6 meter. And an angle of elevation is 41. So you can write in both ways. So that's perfectly fine. Now they want to calculate the length of the string, isn't it?
Yeah.
So now all I will do, I will keep my eye here. When I keep the eye, I will connect what I know and what I need to find out. I know it's 8.6, which is the opposite one, right? What I want to find out sitting on the hypotenuse. So what relationship connect the angle with the opposite and the hypotenuse? Which ratio?
Sine.
Sine. I don't know. Let's call it L. Now you need to solve for the L. 8.6 divided by sine 41. Make sense? Are you following that?
I got 13.1.
That makes sense. That many meters. All right. All right. All right. So can you do 14? Two guy wires supporting an 8.5 meter TV antenna, each from an angle of 55 degrees with the ground. The wires are attached to the antenna 3.7 meter above the ground. The wires are attached to an antenna 3.7 meter above the ground. Using a reciprocal trigonometric ratio, calculate the length of each wire to the nearest tenth of the meter as what assumption you have made. So the big challenge is you need to draw the diagram. Anyone know how that will look like? Yes. If you don't visualize it, this problem you can't answer it. So two guy wires with a supporting an antenna. So basically you have an antenna and then an 8.5 meter. Okay. So we're gonna have this is basically here. The two guy wires supporting an 8.5 meter TV antenna. So this is basically 8.5 meter TV antenna. Each from an angle of 55 degrees with the ground. So what that basically is saying is there are two wires. The guy was supporting an 8.5 meter TV antenna. They're supporting that guy wire with an angle of 55 degree. So this is basically making 55 degree. And then this is also supported by making a 55 degree. Are you guys following the diagram? Yes. Now, the wires are attached to the antenna 3.7 meter above the ground. There's one thing I need to make sure in the diagram. The two guide wires supporting 8.5 meter TV antenna, each from an angle of 50 degrees ground. That makes sense. The two wires are attached to the antenna 3.7 meter. The two wires are attached to the antenna 3.7 meter above the ground. Right. One thing that's confusing is the 3.7 meter. Two guy wires supporting an 8.5 meter TV, 8.5 meter TV antenna. That makes sense, antenna. And each from an angle of 55 degree with the ground. So we have 55 degree with the ground, both sides. But the only problem is the wires are attached to the antenna. The wires are attached to the antenna. The wires are attached to the antenna 3.7 meter above the ground. That distance is 3.71 meter. But why do you need that distance? 55 degree. That's not really useful.
What if he just is just there to like throw you off?
What?
What if it's just there to throw you off?
Which one?
Like, what if that thing is just there like to like make you confused?
What do you say, sir?
Like, you know how it's saying it's 3.7 like meters above the ground?
Yeah.
What if it's just like useless and you just don't need it? It's just there to like confuse you.
Using reciprocal ratio is fine. Well, that can be possible, yes. Using the reciprocal, calculate the length of each wire. But if I want to calculate the length of each wire, it's pretty straightforward. I'm not sure why do I need to calculate both wires, because that's obviously, you guys know, you can use a SOHCAHTOA. It's an isosceles triangle. So if you use a SOHCAHTOA, what ratio will you? Sine 55, isn't it? Make sense? Sine 55 is going to be 8.5 over the length L. L is equal to 8.5 divided by sine 55, isn't it? Okay. Let's see what's the book answer. Can you guys do the math? All right, so I need to see. Which question is this? Question number 14. It is possible they can put that to confuse. That's unnecessary information. Can be there, but let's see. What do you guys get?
13.1. Oh, wait, never mind. I meant 10.4. I got 10.4.
Okay, so basically what the story is, the wires are attached to the antenna 3.7. So what they, it's for sure it's going to be confused. What's happening? There's an antenna. These are the wires, isn't it? So this is 55, no question. This is 55, no question. What they're saying is, if this is the ground floor, this is the ground, you attach to the antenna, this is the attachment on the top. They say this is basically 3.71. Just following that. So the two guys were supporting an 8.5 meter TV antenna from an angle of 55 degree. So what's happening here? So you might wonder, then how come the antenna size is, you might wonder, how come the antenna is 8.5 meter, isn't it? But here's what the picture is. You can't really put the antenna on the ground like touching here. The antenna has some product below the ground. We don't need to worry about it. So it's like that, guys. This is the antenna. This is the ground. Some part of it already inside the ground. Make sense? Now you're attaching two wires to the ground. This is the ground level. Are you seeing the picture?
Yeah.
So what the confusing part is, the antenna's height, in reality, when you're building, when you're supporting, you can't really keep it on the floor and then put two wires to support. You actually dig it further, right?
Wait, so you have to subtract 3.71 from 8.5?
That's right. Did you see that, what the picture is? So the confusing part is the antenna's height, but we don't need to care about it. What's happened in the antenna. So what they're saying is these two wires are attached 3.7 meter from the ground to the top of the antenna. All right. So now you know 8.5 turned back to 3.71. You know how to solve for that. So I shouldn't have any problem. Can we move on? Are you following that? All right. So now we are back to the handout, guys. So in the handout, we're going back to evaluating Regnault-Metal ratio for the special angle. Now, second. All right. So this is where your teacher say no calculators allowed. No calculators. So in a trigonometric unit, there are portions where no calculators allowed. I will explain what does that mean. We want to know the angles for some specific angle. There are two special triangles that you must remember to find the exact trigonometric ratios. These ratios only exist for the specific angle, 30 degree, 45 degree, and 60 degree. So how that look like, guys? Let me going back to 45 degree angle. You can see that the 45 degree angle is just going to be these two sides are equal. In a 45 degree angle, these two sides must be equal. A 45 degree angle, as you know, is an isosceles triangle, isn't it? Two sides are equal. So we can say this side is 1, this side is 1. Make sense? Or you can say 2, 2, but the length is equal. Using our Pythagorean theorem, this distance will be 1 squared plus 1 squared, which is going to be square root of 2. Any question with that? No. Now, you need to remember this guy. This is 30 degree. This is 60 degree. This is a special triangle. When you have a 30 and 60 degree, something you need to remember, the opposite side must be 1. The hypotenuse must be 2. This is the rule of thumb. Opposite side, the ratio between the opposite over the hypotenuse must be 1/2. Now, you all know, using a Pythagorean theorem, this will be 2 squared minus 1 squared, 4 minus 1 squared up, 3. Are you seeing that?
Wait, how you know it's 2 and 1?
Well, that's a ratio to draw a triangle. If you want to draw a triangle with one angle at 30 degree, the other one 60 degree, then your hypotenuse must be 2. The opposite of the 30 degree must be 1. Okay. Otherwise, you can't draw the triangle. We can prove that by geometry if I draw a triangle, but that's a ratio. So you can see the triangle drawn. All right, now what we're going to do is, guys, we're going to write the ratio, sine of 60. So how do I look at the sine of 60? If I keep my eyeball here, sine of 60 is equal to opposite over hypotenuse. What I have on the opposite side, √3. What I have on the hypotenuse, I have 2. So everyone agree sine of 60 is going to be √3 over 2? Yes? Now tan of 45. So how do you find the tan of 45? Opposite over adjacent, isn't it? What I have in opposite? 1. What I have in adjacent? 1. What is 1 divided by 1? It's simply 1. Makes sense? How do I find cosecant of 30? Cosecant of 30, we're going to be going back to the reciprocal of sine. So 1 over sine of 30. So how do I able to find out sine of 30? So sine of 30, if I going back to the triangle, if you can find the sine of 30, 1 over 2. Makes sense? So 1 over 1 over 2. You know when you divide it by 1/1/2, you got 2, isn't it? Are you following that, sir?
Yeah.
All right. Now, using this triangle, we need to list the following ratios. What is sine of 30 degree? Opposite over the hypotenuse, 1/2. What is cos of 30 degree? Adjacent over the hypotenuse, √3 over 2. What is tan of 30 degree? Opposite over adjacent, 1 over √3. Are you guys following that? Okay, copy down, copy down.
Wait, is 3 over 2 in the root or just 3 in the root? Just 3, right?
3 over 2. So 3 over 2. So I will write the 3 over 2 like this. Is it good enough? Now, we don't really like that. It's like that. I'm going to multiply both numerator and denominator by √3. I'm going to multiply that. If I do that, what would I get on the numerator, denominator? And numerator, I wrote 3 over 3. Are you seeing that picture? All right. Now, on the same triangle, I can find the following sine of 60. Sine of 60 is opposite √3 over hypotenuse, √3 over 2. Cos of 60 is adjacent 1 over 2. Tan of 60 is opposite root 3 over the adjacent one. So simply root 3, isn't it? Are you seeing that? Now, sine 45. Opposite over hypotenuse. And then multiplying by root 2 both sides, I can say root 2 over 2. Cos 45 also same here because it's an isosceles triangle, isn't it? Tan 45 is 1 because opposite over adjacent. 1 divided by 1 is just going to be 1. Are you guys following that? Yes, no? Are you guys following that? What's happening? Come on. Okay, can you guys tell me what is sine 45 in that case? I mean, secant 45. Let's see who will find a secant 45 using your ratios.
Is it 2 root 2 over 2?
Sorry?
2 root 2 over 2.
Sine 45, secant 45. It's just going to be less root 2, sir. How come? Because 1 over cos 45. What is cos 45?
Oh, root 2 over 2.
Root 2 over 2. Or you say 2 over root 2?
Yeah.
Oh, yeah. 2 over root 2 is simply root 2, isn't it? Because 2 times root 2 over root 2 times root 2. This is 2 times root 2 over 2, which is simply root 2. Divya, are you following that? What's happening? Yes? No.
Oh, wait.
That's what?
I messed it up a little.
At school, you need to remember this. Now, what your teacher will expect, you can draw the special triangle or you can memorize it. But here's the problem. Memorizing is fine, but it's very easy. You will forget simply which values belong to which. The triangle part, very easily you could forget for 30 and 60. Because 30, you need to know that the opposite is 1, the hypotenuse is 2, isn't it? What if you switch around? Then everything is going wrong, isn't it? So there's an easiest way to remember these values. This is my method. You guys ready? Are you guys ready?
Wait, so how did it end up is just root 2 for
Because this 2 will go up.
Yeah.
So 2 over root 2.
Yeah.
I multiply my numerator and denominator by root 2.
Root 2.
So that's 2 times root 2 over root 2 times root 2 is 2.
Yeah.
Can I cancel 2 and 2?
Oh wait, so the bottom becomes 2. Oh yeah.
Root 2 times root 2 is. All right. This is crucial. You guys need to create the chart. I'm going to show you guys how to remember these values easily. The special angle. So you guys going to create a chart. So I'm going to create my angle 0 degree. The next angle is 30 degree. The next angle is 45 degree. Next angle is 60 degree. Next angle is 90 degree. This is my path chart. Pretty easy. This is the chart you can remember. The only time it doesn't go by 30 is between 30 and 45. You can say 30 to 45 is 15, 45 to 60, 15, that's go by 30, isn't it? Are you just following that? Now, all I want you to remember the sine of, cos of, the tan of the angles. That's something you need to remember. So what we're going to do is, we're going to do some magic. On the top of these angle, I'm going to write a pattern. This pattern, start at 0, increment by 1/4 each time. So what is the pattern I'm going to write? Starts at 0 and increase by each time. So what does that mean? 0. 0 plus 1/4 is 1/4. 1/4 plus 1/4 is 1/2. 1/2 plus 1/4 is 3/4. 3 plus 1/4 is 1. Are you guys following that? Are you following that pattern, sir? It's pretty easy to remember. 0, 1/4, 1/2, 3/4, 1. There's no way things will go wrong on the memorization. Right, Kelman?
Okay, I got it.
What?
I said I got it.
You got it?
Yeah.
0, 0, 1/4, 1/2, 3/4, 1. 0, 30, 45, 60, 90. Make sense? All right. How do I find a sine? You see these numbers? Take the square root of those ones. What is square root of 0?
0.
What is square root of 1/4? 1/2. Yeah. Right? This one, square root of 1 is 1, but square root of 2 is root 2. We can rewrite root 2 over 2, isn't it? 1 over root 2 Can I multiply my numerator and denominator by, 1 over root 2? When I have 1 over root 2, can I multiply my numerator and denominator by root 2, guys? So we learned that in previous lesson, root 2 over 2, isn't it? What is square root of 6? What is square root of 3 over 4? Square root of 3 over 2. What is square root of 1? 1, isn't it?
Yeah.
So the sign values are come as a square root of those values. Now you're going to see the magic. You know what the cost is? Simply reverse them. So when I reverse it, 1 comes here, root 3 over 2 comes here, root 2 over 2 comes here, 1/2 comes here, 0 comes here. Cost is being reversed. No math required at this point to reverse it. Do you know how to find a tan? To find a tan ratio, take the sign divided by cos. 0 divided by 1 is 0, isn't it? Make sense? 1 over 2 divided by root 3 over 2 is 1 over 2 times 2 over root 3, which is going to be 1 over root 3. 1 over root 3, we can rewrite as root 3 over 3, isn't it? So that is root 3 over. If you divide root 2 over 2 by root 2 over 2, you should get 1.
Yeah.
That is root 3. 1 divided by 0 is undefined. So what you need to master it. You need to master how to create a table. Beginning of the test. You need this. You're going to take grade 12 advanced function. Calculus, you need the table. But very easy. Just you see that pattern 0, 1/4, 1/2, 3/4, 1. What this avoid is memorizing the special triangle. Now, what we want to do is we want to show how to use the exact values to simplify this. Can you guys substitute the exact values I told you to do, please? Go back to your table. You see the table? And substitute the values. Can you simplify the first one, please? Example 2. Water, come back. Substitute from the table. You have the table. You can directly substitute the values from the table. All right, let's see how do you guys do that exit value. What do you get as a result? You substitute the value. Okay, what is sine 45? Root 2 over? What is cos 45?
Root 2 over 2.
What is sine 30?
1 over 2.
What is sine 60?
Root 3 over 2.
Pretty good. All right, what is root 2 times root 2?
2.
2. Make sense? 2 over 4. 1 time root 3, I can really do anything. That is root 3, isn't it?
Yeah.
What is 2 times 2?
4.
Do you have the same least common multiple?
Yeah.
2 plus root 3. Make sense?
That's what I got.
Okay, perfect. Can you guys do B? You done B?
Oh, almost.
Okay, can you do the, are you following that? It's the same as simplifying radicals. Are you following that, sir? You done B? Why is another 2 comes here?
Because there's only two applied.
No. There's a 2 time that time that.
But isn't the two applied?
No. So it's not A plus B. So this is basically 2 times sine 45.
Yeah.
Time cos 45. So it only applies once.
But like if you multiply this and this, then you
No.
Okay.
So think about it. You're multiplying this one with this.
Yeah.
So let's say 2 times 3 times 4. How do I do that? 3 times 4 is 12 times 2. I only multiply by 2, isn't it?
Yeah.
Make sense?
Yeah.
Let's see how you do that. Where's your handout? Where's your work? Which one you're doing? What? Where's the question where you're doing?
Question, right?
Yes. Okay. Why don't you write things on your notebook? Just writing over and over and again. Okay. So let's substitute the values. What is tan 30 is? For 3 over 3, isn't it?
Yeah.
Make sense? Are you following that, Divya? All right. 2 times sine 45 is root 2 over 2. Cos 60 is 1/2. Can I chop these 2's? So root 3 over 3 plus root 2 over 2. Now let's look at a fraction. What is the least common multiple?
6.
6, right? So I need to multiply this one by 2. And I multiply by this one by 3. Makes sense? Yes?
Yeah.
Are you following that? And I multiply that one by 2. And I multiply, that's it. Nothing you can do. All right. Before we going back to example 3, example 4, example 5, I'm going to give you guys a task. Are you ready? So this is a practice on the side. Sine 45, cos 30. Actually, give me just give a different question. Cos 60 times cos 60 minus sine 60 times sine 60. Can you simplify that, please?
We are multiplying them?
Yeah. Tell me what do you get at the final answer?
Negative 1/2.
Let me wait for this guy. How about you? Divya? What did you get for cos 60? What did you put for cos 60? 1/2 times 1/2. Sine 60 root 3 over 2 times root 3 over 2. So 1/4 minus 3 over 4, isn't it? So minus 2/4 negative 1/2. Makes sense? All right. Now, let's go back to the next type of question. So your theta is going to be between 0 to 90. But if a cos of theta is root 3 over 2, they want you to find the theta. Can you just go back to the table and find out what should be the theta to get cos of theta is root 3 over 2? On the table, or what value of theta you got cos of theta root 3 over 2?
30 degrees.
That's it. So therefore, theta must be 30 degrees. Makes sense? But the only difference here is I need to isolate it for sine of theta. So sine of theta is 1/√2. So Aaron, can you tell me what value of theta, sine of theta is 1/2? 45 degrees. Pretty good. All right. Let's do a quick practice. Root 3 cos theta minus 2 is equal to 0. Can you find out what should be the theta to make that equation 2? My bad. It's 2 here, 2 here, 2 here, root 3 here, 2 here, root 3 here. Okay. Can you just find out what should be the value of theta that will make that true? Somehow isolate for cos of theta. Then it's pretty easy. All right. What do you guys get for theta?
30 degrees.
Pretty good. You got theta is 30 degrees. So how does this work? We move the root 3 to the other side, right, Divya? Now, how the cos theta will be root 3 over 2. Now, from the table, we can say theta must be, 30 degrees. Make sense? I just follow that?
Yeah.
All right. Can you guys do example 4, please? You have to prove that 1 plus tan squared theta is secant squared of theta, where theta is 45.
What Harley was asking. What's it asking?
So we're going to take the left side and then substitute theta 45. Right side, substitute theta 45 and prove both of them are equal. Who has prove it? Who did the proof? All right. Who prove it? You prove it, sir? You got both sides same?
Yeah.
Pretty good. What do you got both sides?
2.
You got 2. You prove it? What do you got?
2.
Okay, so we're gonna left hand side. 1 plus tan squared up theta. And then 1 plus tan squared up 45. What is tan 45 is? 1, isn't it? So 1 plus 1 squared, which is going to be 2. Now right hand side, secant squared up theta. So something that you need to be really careful. Secant squared up theta means secant theta whole thing squared. That is what that means. You square the value, not the theta. Make sense? So secant squared is 1 over cos of theta squared. So what is the theta value? 1 over cos 45, isn't it? Now, what is 1 over cos 45? 1 over root 2. And then that's basically root 2 squared, which is also 2. So that's confirmed the left-hand side is equal to right-hand side. Are you just following that?
Yeah.
All right. Now a little challenging for you guys. Given a triangle ABC is shown, determine the exact area of the triangle if sine of theta is 1/2. So your triangle is given. You want to find the exact area. How would you find the exact area? Base time, height divided by 2, isn't it? So I know this was 14, isn't it? So area is going to be the area of triangle ABC, base time height divided by 2. What is my base here? AC, isn't it? What is my height here?
14.
Well, we know 14 divided by 2 is 7 times AC. You're tasked to find the distance of AC exactly. So can you do that? Good answer. Anyone else have an exact value? So find the AD, separate, and find the DC separate and add them together. The task for you guys you need to find the distance of AD separate and then find the distance of DC separate and then add them together. Make sense? Because you know 45 and you know one side, you can find the AD. You know theta, sine of theta is given to you in 1/2. You don't need to know the angle, but using that, you can write a trigonometric ratio to find a DC, isn't it? Does it make sense? Killman?
Yeah.
I think that you guys are keeping the 1 week break in November, right? The principals say.
I'm not sure.
I think so. They just want to keep it. All good?
Yeah.
What do you have, sir? So tan 45 is 14 over 80. 80 is 14 and okay, pretty good, yes. And then you also need to find a DC.
Yeah, that's not right now.
Okay. Has everyone got 80 is 14? It's pretty obvious because of 45. It's 45 is an isosceles triangle. If these two sides must be equal, so 80 must be 14, isn't it? So how do you find a DC? Well, keep the eyeball here, isn't it? If you keep the eyeball, 14 is opposite, isn't it? Make sense? Over DC. What is sine of theta is? Do they give sine of theta is equal to 1/2, isn't it, guys? Yes. So what is DC is equal to? 28. Make sense? Right? So therefore my AC, 7 times AC, 28 plus 14. So 7 times 42. We don't know what unit is some squared. Are you following that?
I got messed up over here. Wait, what were you supposed to use to find DC?
I think I messed up. You're right. That's right. I messed up here. That's right. 80 is 14 is correct, but not done yet. But you only know sine of theta is 1/2, guys. So you can't really use the sine ratio to find that DZ. Let's go back here. That's a good question. This is theta, isn't it? This is 14. What I need to find out, I need to find out DC. To find a DC, what I need to know tan of theta, right? Can I use sine of theta to find a DC? Huh?
Yeah.
How? Because this is opposite, but this is not hypotenuse. So can I use sine of theta to find a DC?
Yeah, because
No, I can't.
Oh.
I can only use tan of theta. Are you following that? Because they only give sine of theta ratio. So now let's going back to the diagram. In this diagram, if sine of theta is 1/2, what that really mean? Sine of theta is 1/2. When this is opposite side is 1, the hypotenuse have a ratio of 2, isn't it? Make sense? That's what sine of theta is. Opposite over hypotenuse, right? Can I find out this side then? This is going to be 2 squared minus 1 squared. How big is that? 3, isn't it? So what is tan of theta then? Tan of theta is equal to opposite over hypotenuse, which is 1 over √3, right? Now let's going back to that logic here. if I keep my eyeball here, to find the DZ, I need to find the ratio of tan of theta, otherwise I can't. So I can say tan of theta opposite 14 over DC, isn't it? What is tan of theta? 1 over root 3. Did we find that? Divya, are you following that? So 1 over root 3 is equal to 14 over DC. From here, DC is equal to 14 root 3. So what is AC is equal to? AC is equal to AD plus DC, isn't it? AD 14, DC is 14 root 3. Now we don't really like the 14 in both places. We can take the 14 as a common factor. So 7 times 14 outside, 1 plus root 3. We'll simplify what is 14 times 7.
Wait, how'd you know it's 1 over root 3?
So what do we know about it? Sine of theta is 1/2, right?
Yeah.
So if you draw a right angle triangle, sine of theta mean opposite over
Hypotenuse?
hypotenuse. So this should be 2, isn't it?
Yeah.
Can I calculate this distance supposed to be using Pythagorean theorem? 2 squared minus 1 squared, right?
Yeah.
So which is going to be giving me 4 minus 1, which is root 3. Can I then write tan of theta? What is tan of theta? Opposite over adjacent, isn't it?
Yeah.
So if I keep my eyeball here, what is the tan of theta? Opposite over adjacent,
Okay.
right?
Yeah.
And then we can simplify 14 times 7. So 70, 28, 98 times 1 plus root 3. Are you guys following that? All right. I think that if I want to moving back to my next lesson, it's too much to digest. So we will going back to some textbook question. So next class, we will work with that 5.3. And then when you finish 5.3, a lot of practice on 5.3 required. After 5.3, 5.3 is not easy. You guys will find, oh, what is going on? And then solving for the equations. Did they introduce identity here? Oh, yeah. All right. So we will come back to 5.3 next class. So what I'm going to do, we want to do some practice before we wind up on a textbook on this. All right, let me pull out the textbook. 5.2. So if you guys get things on there, I think I did pretty much some good question. Questions to practice. Where's it? Well, I'm not sure where this is going all the time. Okay, I'll show the picture one more time. Yeah, put in the right place. So I say OneNote, MCR3U. Semester 1. Oh, no. MCR3U. I think that Math Emperor Summer 2024. That was a problem. It's going to the right place. Okay, here we go. All right, guys. Let's see. All right, now it should be in here. All right. Look at that question number 11. Determine the exact area of each triangle. Can you guys give a shot on first one? Triangle A. It's a very similar type of question.
Wait, what does that say? Tan what equals 1?
Tan alpha. There's a little angle.
Oh.
All right. Is that difficult again?
Not really.
Same idea, isn't it? Half time, base time, height, right? For example, here, you know the 6 is the height. So you need to find the base, isn't it? How will you guys find the base? Did they provide enough information to find the base? They did. And that same idea, using that information, you can also find out that other base BC, isn't it? Aaron?
Yeah.
Done?
No.
Thinking?
So big.
Okay. So here's the hint, guys. I need AB, isn't it?
Wait, what do we round to?
You don't round it. It's the exact area. No rounding. Exact area, I mean, there's no calculators involved.
Oh,
So if you guys can't see for this question, I need to find the AB, isn't it? So if I want to find the AB, I see that AB is for the alpha. If you guys really look at the picture, the distance AB is for this alpha. Is the adjacent side, isn't it? Right? And then I knew the opposite side, which is 6. So what is tan of alpha? Opposite over AB. Did I get how much tan of alpha is? Didn't they give what a tan of alpha is? Don't they give the tan of alpha is equal to 1? Did they provide that information? So can I substitute tan of alpha as 1? So AB is equal to 6. Everyone got that part? Yes? Aaron?
Yeah.
Now I want to find a BC. So look at the BC. If I keep my eye here, guys, tan of 60 degree is the opposite BC of the adjacent 6, isn't it? Because 6 is common side for both triangle, right?
wait, I found BC.
That's okay. Just you find the BC. How much is BC?
Oh, I got 6
6
root
times?
3.
Yes, 6 root 3 because tan of 60 is root 3, right? So the total basis AC is going to be AB plus BC, which is 6 plus AB 6 root 3, right? Can I write 6 times 1 plus root 3? Yes. All right. So how do you find the area? Area is half time. Base is 6 times 1 plus root 3. Time height is 6, right? Can I simplify that 3? 18, 1 plus root 3. I'm just following that. Guys. Are you following that? So how does it work?
Yeah.
Exact value. Kelvin. What part
I'm
did
just trying to find AB right now.
AB?
Yeah.
So to find AB, we use the tan of alpha. Tan of alpha is opposite over adjacent, right?
Yeah.
But tan of alpha, they give it to us. How much?
1.
So I use that to find the AB.
Oh, so you did. So tan alpha equals
6 over.
AB, and then
All right, guys. So next class, we're going to go back to the crazy step. Really, really crazy step. Because you only learn trigonometry to right angle triangle. You never find out a ratio for any angle greater than 90, did you? Have you ever find out? But next class, we're going to learn how to find the trigonometric ratio for any angle greater than 90. Any angle greater than 90. So that's required a lot of understanding what's going to happen. So don't miss the class. Because so far what I did, the new thing you have learned is the exact value. Other than that, it's SOHCAHTOA and reciprocal, isn't it? So next few classes going to be fun. I did 5.1 and 5.2. I think if I remember from the textbook. So we're going to go back to 5.3, 5.4. I want to see sine law and cosine law comes again. So that's something good news because you're going to learn something you have learned. Cosine law, sine law comes again, 5.7. They have a 5.8 3D problem. Oh, yeah. So 5.6, 5.7, 5.8, you have learned before. 5.3, 5.4, 5.5, something you didn't learn yet. So that is what will come back to the next classes. So next class, I will do 5.3 and 4. And we will go for that. So it will take good amount of time in November. So I have 17, 724. Yeah, these are the 2 classes. We will finish the chapter 5. Then we go to chapter 6, is also trigonometry. In chapter 6, you learn the graph transformation of a trigonometric function. Chapter 7 is easy. So I'm in good track. I'm completely in good track to complete this at the end of December. Anyone